So this video is going to discuss how we solve a system of linear inequalities. So let's look at this word problem situation here. So Mrs. Gallus is opening a small bakery. She needs to figure out how many muffins and cupcakes to bake. Both types of baked goods are baked in the same type of tin. Let M represent the number of muffins and C represent the number of cupcakes. Question 1. Mrs. Gallus only has 5 baking tins, which can hold 12 items each, muffins or cupcakes. So the total number of muffins and cupcakes cannot be more than 60. We get that from doing 5 times 12. Write an inequality to represent this idea. So we know that the number of muffins plus the number of cupcakes cannot be more than 60. So M plus C, muffins plus cupcakes, is less than or equal to 60. So give one possible solution for the number of muffins and cupcakes she could make. So for instance, she can make 10 muffins and 40 cupcakes because 10 plus 40 is 50, which is less than or equal to 60. So that's one possible solution. So now let's go ahead and graph it on the next page. So our inequality here is M plus C is less than or equal to 60. And notice that I changed the color here. I changed it to blue. So when you're solving a system, which is multiple inequalities on the same coordinate plane, you're going to want to graph them in different colors, and you're going to want to shade them in different colors to make the solution a little easier to see. So if M plus C is less than or equal to 60, we know that our intercept for the muffins is going to be 60. And we know our intercept for the cupcakes is also going to be 60. So that's my 2 points. So now it's less than or equal to, so we know it's going to be a solid line. So then I could just draw something that looks like this. Now, where do we shade? So we already tested a point. We know that 10 muffins and 40 cupcakes is a possible solution. So 10 muffins, 40 cupcakes is over here. So that tells us that we're going to shade on this side here. Now notice I'm not shading in the negative because it wouldn't make sense for us to have a negative number of cupcakes. We're really just working in the first quadrant here, right? So that's our first inequality. Now let's look at our next constraint. And constraints are what we're calling each of these different kind of restrictions that Mrs. Gallus has to put up with or deal with as she's planning. So Mrs. Gallus knows she will need at least 20 muffins. So write an inequality to represent this idea. So M is the number of muffins. So we know that then M is greater than or equal to 20. So now what's one possible solution for a number of muffins she could make? Well, she could make 30 muffins because that's greater than or equal to 20. And how many cupcakes? Let's say 40 cupcakes. Now notice that as I am coming up with the possible solution here, I'm ignoring the first constraint. We know that, yes, the first constraint, the sum has to be less than or equal to 60. That's not what we're talking about here. We're treating the fact that she needs at least 20 muffins separately. So let's go ahead and let's graph that. So I'm going to choose a different color. I'm going to graph this one in red. And it's M is greater than or equal to 20. So if M is greater than or equal to 20, this is really a vertical line because we're only dealing with M here. So that tells us that at 20, we're just going to draw a vertical line like this. And now notice I'm putting an arrow at the top part. The bottom part doesn't get an arrow though because it doesn't make sense to go negative, but I could go higher than 60, right? Like there's nothing that stops me from that. So now our test point, just as a reminder, was 30 muffins and 40 cupcakes. So 30 muffins, 40 cupcakes is over here, and we know that that works. So the side that we're going to shade is going to be this right here, right? So it's all of this here. Okay. So now I hope you're beginning to see why the different colors are important. Because in order to solve this, we're going to have to see where all of these things are true at the same time, right? So now let's go and let's look at our next constraint. Mrs. Gallus knows that she sells at least as many cupcakes as muffins. So write an inequality to represent this idea. So basically what she's saying here is she's going to sell more cupcakes than muffins. So C is greater than or equal to M. So yes, greater than, but also equal to. It's possible that she sells the same number of cupcakes and muffins. So what's one possible solution here? Well, she could sell 35 muffins and she could sell, 50 cupcakes. In that case, C is greater than or equal to M. So now let's go ahead. Let's change our color. I'm going to do this one in yellow. So we have C is greater than or equal to m. And this is going to have a x and y intercept, or a c and m intercept of 0. And then our slope in this case is 1, right? So I could plot a point here, for instance. I could plot a point here, for instance. And it's going to be this line like this. Put an arrow there because it goes on infinitely, but a point at the origin because we can't go lower than 0. And now our test point was 35 muffins, 50 cupcakes. So 35 muffins and 50 cupcakes. So 35, 50, which is over here. That's our test point. That's our solution there. So we know that then we are going to shade above this line. So we're going to shade this way. Okay. So now we have our solution set, which we'll talk about in just a second. So now those are all of our 3 constraints. So we have the total number of items can't be more than 60. We have to sell at least 20 muffins, and the cupcakes have to be the same as the muffins or higher in terms of their sales. So there's our graph. So give a possible number of muffins and cupcakes that works with all of these things that Mrs. Gallus knows. So where all of those things are true is going to be in this area here, this triangle. That triangle is super important because that's where all 3 constraints, all 3 colors overlap. So any point in that area is going to work. So for instance, 25, 30 is this point here. That's 25 muffins and 30 cupcakes. That is true for every single one of those. So if I did 25 muffins and 30 cupcakes, let's test it out with the constraints. If I added them together, 25 plus 30, I get less than or equal to 60. The number of muffins is 25, which is greater than 20. And the number of cupcakes is 30, which is greater than or equal to 25. So all of those constraints are true. So now for our next question, if we take all 3 of the inequalities above, we create what's called a system of inequalities. Is 30/20 a solution to the system of inequalities? So now let's look. I'm going to plot this one in green. If I plotted 30/20, is that a solution to the system? Well, no. Now, what does it violate? Well, it violates the fact that there have to be more cupcakes than muffins. If I have the point 30, 20, well, that violates this here because the number of muffins is going to be greater than the number of cupcakes in 30, 20. So that violates that one. And you could see that because the area that's shaded in yellow is on the opposite side, right? So we could tell that that doesn't work for that reason. For the next question, is 20/20 a solution to the system? And explain. So if I look at the graph and I looked at 20/20, well, 20/20 is an interesting one because it's actually right over here. And that is a corner point on our triangle. Because what's interesting about 20/20 is at that point, 20 is greater than or equal to 20. And then 20 is greater than or equal to 20. That and that matches this and this because the muffins are greater than or equal to 20 and the cupcakes are 20, which is equal to the muffins, which is 20. And then for our last constraint, 20 plus 20 is 40, which is less than or equal to 60. So that's a corner point there. And being at a point of intersection of 2 or more constraints is perfectly fine. So yes, 20/20 is a solution. Find 3 solutions to the system and plot them on the graph. What do you notice? Well, I could just plot any 3 points in this area. I could pick this point here, this point here, this point here, this point here. Really doesn't matter, right? So something like 22, 30, that's a solution. Something like 20/35, that's a solution. Something like 25/30, that's a solution. As long as it's within that triangle, any possible combination of muffins and cupcakes will work, provided, once again, that it's in the overlapping area where all of the colors are existing. Let's try another example together here. So graph the system. Y is less than or equal to negative 2x plus 6, and x minus y is less than 6. So once again, multiple colors is super important. I'm going to choose blue for the first line. So y is less than or equal to negative 2x plus 6. So let's graph the line. We know the y-intercept is 6. We know that the slope is negative 2, so you could use the slope if you would like to, or you could plug in a point. If I plug in 2 for x, that's going to give me negative 2 times 2, which is negative 4, plus 6, which is going to give me positive 2. So it tells me that 2 is there. It's less than or equal to, so that's going to be a solid line. So we could actually go and connect our line, make it look something like this. Okay. Now for our next one, well, actually, let's shade it first. So we want less than or equal to. So let's test a point. Let's test 0, 0. So 0 is less than or equal to negative 2 times 0 plus 6. 0 is less than or equal to 6. That's true. So we're going to shade this side here. Okay. Next up, x minus y is less than 6. I'm going to graph this one in red. X-intercept, 6. Y-intercept is going to be negative 6. And now let's connect that. So it's a dash line. And it is less than. So let's go ahead and let's test a point. 0, 0. So 0 minus 0 is less than 6. 0 is less than 6. That's true. So we're going to shade up here. So now where is our solution? Well, the solution is where both overlap. So it's going to be this area over here. That's the solution to the inequality. So when you're graphing these, you really want to have multiple colors, whether it's pen and pencil, or you have colored pencils. Feel free to use those things as you're solving these problems.